Right. So this is the fifth lesson in the algebra series. Right. So today we are going to discuss zeros of a polynomial, then the remainder theorem and the factor theorem. Right. So we'll first look at zeros or roots of a polynomial. Right. So let's start with the standard polynomial of degree n. Then we say that a is a zero of the polynomial if and only if this happens. What should happen? When you substitute x equals a into the polynomial value has to be equal to 0. So any x value where the polynomial has a 0 value is called a zero of the polynomial or a root of the polynomial, right? So for a degree n polynomial, you will have n number of zeros. So for a degree 3 polynomial, you have 3 zeros, 3 possible zeros. Then for degree 5, you can have 5 zeros, right? So let's do an example, right? So let's consider this polynomial, right? This is a degree 2 polynomial, or it's a quadratic, right? So to find the zeros, we need to find x values where the polynomial value will be equal to 0, right? So the method to find in polynomial zeros is factor it. So this one, I can use the difference of squares. I can write 25 as 5 squared, then use the difference of squares formula and factorize this into x minus 5 plus x plus 5, right? So now observe that when x equals 5, that comes from the first factor, equal the first factor to 0, okay? Equal the first factor to 0 and solve for x. So you get x equals 5 now. So now try substituting that into the polynomial. So what happens? P of 5 is what? 5 squared minus 25, which is 0. So what does that mean? Then x equals 5 is a 0 because P of 5 is 0, right? So we know one solution or one root, x equals 5. Then you can do the same thing for the second factor, equal it to 0 and solve for x. Then you will get the second 0. You can verify that by substituting it into the polynomial. So what is happening when it is minus 5? P of minus 5. So minus 5 squared minus 25. Again 25 minus 25, 0. So that means what? X equals minus 5 is also a 0. So this polynomial px has two zeros. What are those two zeros? X equals 5 and x equals minus 5. Two zeros at x equals 5 and x equals minus 5. Let's do another example. So right, so this is what? This is a cubic polynomial in factored form. So how to find the zeros? Equal each factor to 0 and solve. So this gives you x equals 1. Second factor equal to 0 and so you get what? X equals minus half. Then do the same thing for the third factor, x plus 3 equals 0 or x minus 3. So what are the zeros? Zeros are x equals 1, comma, minus half and minus 3. So that is how you find zeros of a polynomial or the roots of a polynomial, right? So remember the condition. Any point where the polynomial has a 0 value is a 0 of the polynomial, or it's called a root of the polynomial, right? Now let's look at one of the important theorems in algebra, remainder theorem, right? So regarding polynomials, right? So let's read the theorem. If the polynomial fx is divided by x minus a, then the remainder is the value f of a, right? So remember, remainder theorem only works for this type of devices, okay? It doesn't work for any other type of devices. So you have a polynomial and it is divided by what? X minus a. We can actually generalize this into this form, ax minus b. That also works. So for the proof, we will use the easier one, x minus a. So remember, this theorem works for only linear devices. So what are those? Linear devices have this form, ax plus b or minus b, it doesn't matter. So this type of devices, ax plus or minus b, okay? It can be plus or minus, it doesn't matter, right? So this theorem only works for this type of devices, right? But for the proof, we will use the easier case, x minus a. So let's see. So now we know our divisor is what? X minus a, and our polynomial is fx. Then the remainder is the value fa. That is what we want to show, right? So now observe that what is the divisor? Divisor is x minus a. So this is what? Linear. So remember, when we did division algorithm, remainder is going to be then what degree? Divisor is what? First degree, no? Then the remainder is 1 less than the divisor degree. So r of x is going to be what? Degree 0. Degree 0 is what? Degree 0 is just what? Just a constant. So the remainder is going to be a constant. So we can take it as r. Now our objective is to show r is equal to f of a, right? We took this as r because why? Remainder degree is 1 less than divisor, right? So when the divisor is linear, remainder has to be constant. That is why we take it as r, right? Now let's write the division algorithm form. We want to divide fx by x minus a. So then what is we are going to use the second form of the division algorithm. So f of x is equal to what? The quotient times the divisor plus the remainder. What is the remainder? Remainder is r, right? Remainder is r, right? So that is what we have. So let me make it as equation 1. Now we want to find the r value, no? So then I have to get rid of this part. How can I get rid of this part? The first term. I can just get it, substitute what? X equals a. Then what happens? This whole thing becomes 0, no? So let's do that. Sub x equals a into 1, right? So what do you get? F of a, q of a minus a plus r. This term becomes 0 because a minus a is 0. Then what happens? R equals f of a. Correct, no? Our proof is done. Remainder is equal to f of a, right? So this is a proof you should know. Sometimes they will ask it in the past paper questions, right? So this is a short proof using the division algorithm, right? Okay. So remember, any polynomial divided by a linear divisor, the remainder is always going to be what? F of a. Okay, f of a, right? Okay. Now, right, let's do couple of examples, right? Look at exercise 1, right? So we want to find the remainder when this polynomial is divided by x minus 3, right? So we can use the remainder theorem. Let's take the polynomial to be fx. So 3x cubed plus 8x squared minus 12x plus 2. What is the divisor? X minus 3. So what is the remainder going to be when we divide this polynomial by x minus 3? Look at the remainder theorem. We need to find the a value. So a value is what? To find the a value, remember this is the easy way. Equal the divisor to 0 and solve for x. That is your a value. So here a value is going to be 3. So what is the remainder going to be then? Remainder is equal to what? F of 3. So substitute 3 into the function and find that value. That is the value of the remainder. Minus 12 times 3 plus 2. So simplify and see what you get. 81, 72 minus 36 plus 2. So what is the remainder then? You get 32, 36, 38, 190. So when you divide this polynomial by x minus 3, remainder is going to be 190, right? Okay, now let's do the second one. So again a cubic divided by x plus 1, right? X plus 1. Fx, let's take it as fx, 3x cubed minus 2x squared minus 1. What is the divisor? X plus 1, right? So if the divisor is linear like this, we can use the remainder theorem to find the remainder. So what should you do? Equal the divisor to 0 and solve for x. So x equals minus 1. So then the remainder is going to be f of minus 1. Put this inside the function. F of minus 1 is the remainder. So let's find that. Remainder equals f of minus 1. It is going to be what? 3 minus 1 cube minus 2 minus 1 square minus 1. So minus 3 minus 2 minus 1. So minus 6. So the remainder is minus 6. Right. Let's look at the third one. Now a quartic, a fourth degree. It's divided by 2x plus 1. Let's see how to do that one. So again, let's take fx as the polynomial, 2x to the 4 minus 3x cubed plus x squared minus 2. What is the divisor? Right, 2x plus 1. Okay, so this is still a linear factor. Then you can always use remainder theorem. This is first degree divisor. So this is linear. So then you can do what? Equal it to 0 and find the correct x value. So you get what? X equals minus half. So the remainder is going to be what? F of minus half. You substitute x equals minus half here. So remainder when this polynomial is divided by 2x plus 1 is f of minus half. So substitute and simplify. 2 to the minus half to the 4 minus 3 minus half cubed minus half squared minus 2. Right, simplify. 2 over 16 minus minus cancel, plus 3 over 8 plus 1 over 4 minus 2. Right, now just simplify this and we'll get the answer. So what is the answer going to be? Let's do 16. So 2 6 4 minus 32. So you get 10 12 minus 20 over 16 or minus 5 over 4. Right, so the remainder is minus 5 over 4. Right, so we can use remainder theorem to find the remainder when the divisor is what? That is the important thing. Divisor is linear. If the divisor is linear, use this to find the remainder. Don't use long division. That takes more time. Okay. So better to use what? Better to use the remainder theorem to find the remainder. Right. When the divisor is linear. Right. Next important theorem in polynomials is factor theorem. Right. So let's read factor theorem. Proof of this is also required. So you should know how to do this also. Proof. Right. So again we start with a polynomial fx and has a factor x minus a if and only if this happens. F of a equals 0. So if polynomial fx has a factor x minus a, then that implies what? F of a equals 0. And if you know f of a is equal to 0, then x minus a is going to be a factor of the polynomial. So if and only if means you have to show both sides. Right. So let's do the proof. Right, we'll go in this direction first. So then our assumption is what? Fx has a factor x minus a. Okay, then we have to show what? F of a is equal to 0. That means what? A is a 0 of the polynomial. Right, let's show that. So suppose fx has a factor x minus a. Then let's write down the division algorithm form. So what is it going to be? Fx is equal to what? Quotient times x minus a. What is the remainder? If it is a factor, remainder is what? 0. No? If it is a factor, remainder is 0. Right? So remember that. Remainder is 0. So that is equation 1. You don't need to actually write the 0. I just wrote it to show you that remainder is 0 when x minus a is a factor. Right. Now what do we want to show? We want to show f of a is 0. So substitute x equals a into the first equation. Sub x equals a into 1. What do you get? F of a, q of a minus a. So this becomes 0. So then f of a is what? Equal to 0. So first part of the proof is done. So we went in this direction. When f x minus a is a factor of the polynomial, f of a is equal to 0, or a is a 0 of the polynomial. Right. Now let's do the other direction. Other direction is what? In this direction. Then what do we suppose? We suppose f of a is 0. That means what? A is a 0 of the polynomial. Suppose f of a equals 0. Okay, now let's divide fx by x minus a. Okay, then by remainder theorem, what do we know? Okay, what do we know by the remainder theorem? Fx can be written as what? We are dividing fx by x minus a, no? Quotient times x minus a plus the remainder, no? And we know remainder is r or constant, but because x minus a is what? The linear factor from the remainder theorem, what do we know? Remainder has to be what? F of a, right? So this is from remainder theorem. From remainder theorem, we know if you divide fx by x minus a, remainder is going to be f of a, right? So we have that, right? Now what was our starting point? Fa was equal to what? F of a is equal to 0. So then what happens? Q of x times x minus a plus 0, because why? We know f of a is 0. So what does that mean? F of x equals qx times x minus a. Then what happens? Then there's no remainder, no? So then x minus a has to be what? Factor of the fx. Minus a is a factor of fx. So then the full proof is done. We went in both directions, right? So remember that. So this theorem says what? If fx has a factor x minus a, f of a is going to be 0, okay? And if f of a is 0, you know x minus a is a factor of the polynomial, right? So let's do some examples to illustrate this, right? So look at exercise 2. Find a polynomial of degree 3 that has zeros 3, 0, 1 and the coefficient of x is 6, right? So let's see. Our polynomial has to be degree 3 and we have 3 zeros, right? What do we know? 3 zeros means what? Let's take our polynomial to be f. F of 3 is 0. F of 0 is 0. F of 1 is 0 because they are zeros of the polynomial. Then from the remainder theorem, what do we know? If f of 3 is 0, sorry, not remainder theorem, factor theorem. What do we know from factor theorem? F of 3 is equal to 0 means what? X minus 3 is a factor of fx. And similarly, f of 0 is 0. That means again, x minus 0 is factor of fx. Similarly, because f of 1 is equal to 0, we know x minus 1 is a factor of f of x, right? So now we can write what? Factored form of our polynomial. That's going to be what? X minus 3 times x minus 0 times x minus 1. So this is same as what? Let me write x first. X minus 0 is just x, no? X minus 3, x minus 1, right? Then, so this is what degree? This is third degree, no? Right, degree 3. What we want? A degree 3 polynomial. If it has 3 factors, we have 3 linear factors, it has degree 3. So let's expand this. So x squared minus 3x, x minus 1, again expand, x cubed minus x squared minus 3x squared plus 3x, right? So you have x cubed minus 4x squared plus 3x. Right, this is a polynomial of degree 3 with those three zeros. Right, is it the one we want? It has degree 3 and these three zeros, but there's an additional condition that has to be met. Coefficient of x is what? 6. What is the coefficient of x in here? It's what? It's 3. So the correct polynomial we want is what? 2 of fx. We can take the correct polynomial as px, then 2x cubed minus 8x squared plus 6x. That is the polynomial we want. It has what zeros? 3 0 and 1 as zeros, and it is degree 3. And now it has coefficient 6 at x. So that is the polynomial we want. So this is an application of the factor theorem, where we use, if we know something is a 0, it's also going to be a factor. Using that, we created a degree 3 polynomial. Right. Okay, let's do some more examples. Right, so let's look at this exercise. Right, so this one, what are they saying? Given that this is this fourth degree polynomial is divided by x squared minus 1, the remainder is 2x plus 3. Find the values of a and b. Right, can we use remainder theorem or factor theorem here? What is our divisor? Look at the divisor. Is it linear? Our divisor is x squared minus 1, so it is not linear. So then you can't use factor theorem or remainder theorem. So then you have to use what? Division algorithm to do these types of questions, right? So then let's write down what is given to us. This polynomial, right? 2x to the 4 plus x cubed minus x squared plus ax plus b. So when you divide this by x squared minus 1, you will have a quotient, then the divisor plus, what's the remainder? Remainder is 2x plus 3. That is given, no? It's correct also, no? Divisor is second degree, then the remainder has to be first degree. So 2x plus 3. Let's write that down. Okay. Okay. So now how many unknowns do we have? 2 unknowns. We need to find 2 unknowns. So then we have to create couple of equations, 2 equations. So how to do that? And we don't know the quotient. No? We don't need to find that quotient. What we need to do is substitute values such that this term becomes 0. The term associated with qx becomes 0. Then we don't need to worry about that. No? Right? Then this becomes 0 means we can get an equation involving a and b. So we have to do it in 2 ways. So how to figure that out? Look at your divisor, factor it. Then you will see how to make the term 0. So x squared minus 1, factor it. How can you factor it? Difference of squares. So it's going to be what? X minus 1, x plus 1 plus 2x plus 3. So let me write that as equation 1, right? So what I'm going to do is, I don't want to find the quotient, right? They didn't ask me to find quotient. So I'm going to substitute values that make this term 0, this full term. So what are the values I can use? I can use x equals 1, right? From this factor. If I substitute x equals 1, this becomes 0. So the whole thing becomes 0. So that's what I'm going to do. Sub x equals 1 into 1, equation 1. So 2 plus 1 minus 1 plus a plus b q1 1 minus 1 1 plus 1 2 plus 3. What happens? This becomes 0 because 1 minus 1 is 0. So what do you get? 1 and cancel. So you get 2 a plus b 2 plus 3. So 2 and 2 cancel. First equation, a plus b equals 3. Right. This is not enough. No, we have two unknowns, so you have to make another equation. So you can use the other factor. You can put what x equals minus 1, and then this term again will become 0. So substitute what? X equals minus 1 into equation 1. So you get what? 2 minus 1 minus 1 minus a plus b q of minus 1 minus 1 minus 1 minus 1 plus 1 minus 2 plus 3. Right, what happens here? Because of minus 1 plus 1 becomes 0, this is equal to 0. And now simplify. This one will cancel, you get minus a plus b minus 2 plus 3 is what? Plus 1. So second equation. Now solve them simultaneously and we have the answer for a and b. So we can do 1 plus 2. Sorry, let's take this as 2 and this as 3. 2 plus 3 is what? 2 plus 3 is 2b equals 4 or b equals 2. Then from the second equation, what is a? A plus 2 is equal to 3. So a is equal to 1. So that is how you do this type of question. Here you can't use remainder theorem or factor theorem because our divisor is what? Not linear. Okay. Remainder theorem or factor theorem only works for linear divisors, right? Okay, now let's do another one. Okay, what is here? Exercise 4, right? So what is given here? We have a polynomial where f of 4 is equal to a, f of minus 4 is equal to b, f of 0 is equal to 0. We have to show that the remainder when fx is divided by x squared minus 16 is equal to this. Then we have to do what? Find the remainder when fx is divided by that, x cube minus 16x, right? So again, because the divisor is what? Non-linear, we have to use the division algorithm, right? So this is the remainder we have to show, right? So because the divisor is second degree, remainder has to be linear, no? That is why it's a minus b over 8x plus a constant. So we'll take it as mx plus n, and we have to show what? Show m equals a minus b over 8 and n equals a plus b over 2. That is what we need to show, right? So let's take the remainder as that, and now using the division algorithm we can write what? Using the division algorithm we know f of x is equal to what? F of x is equal to quotient times x squared minus 16 equal to, so not equal to, plus the remainder mx plus n, right? So now again the divisor, if you can factor it, then it's easy. Q of x, this is again difference of squares, no? X minus 4, x plus 4. plus mx plus n, right? Let's take this as equation 1. Now we have to use this. We have given 3 values, no, 3 polynomial values. We can use that, right? So f of 4 is what? A. So substitute x equals 4. Sub x equals 4 into what? Into 1. So you get what? F of 4 is equal to q of 4, but because of this 4 minus 4, this term is 0, no? So first term is 0. Then what are you left with? You are left with 4m plus n. So then 4m plus n is equal to what? Equal to a. That is equation 2, because f of 4 is a, no? Right. Similarly do x minus 4, because we know f of minus 4 is b. So what do you get? F of minus 4 equals, first term becomes 0 because minus 4 plus 4 becomes 0. So you get minus 4m plus n. So you get minus 4m plus n equals b. Okay, that is third equation, right? So now let's use those two equations and find m and n, and then we can find the remainder. So 2 plus 3, what happens? 2n equals a plus b, or n equals a plus b over 2. Then I can do what? 2 minus 3. I can get 8m equals a minus b. So m is equal to a minus b over 8. So therefore, what is the remainder? Remainder is mx plus n, or m is what? A minus b over 8 x plus a plus b over 2, right? So the first part is done, right? Now let's look at the second part. Now we have to show what? Find the remainder when fx is divided by x cube minus 16x. X cube minus 16x, right? So what will happen? X cube minus 16x, right? So again, now what can we do? X cube minus 16x. So we are dividing by fx by x cube minus 16x, right? So then what is the, so our divisor is what? X cube minus 16x. So that is what? X squared minus 16, right? So then this is a cubic, no? Then the remainder has to have what form? Remainder has to have, this is a cubic, means remainder has to be quadratic. So remainder has to have this form: px squared plus qx plus r. So we have to find what is p, q and r, right? So again, set up the division algorithm and create 3 equations, and we can solve this, right? So let's write them down. We know what, from the division algorithm, f of x is equal to, let me fully factor this device. I get this, I get quotient and the times divisor plus the remainder we want to find, qx p x squared qx plus r, right? Now use the 4 values. We know f of 4 is what? F of 4 is a. So using that, you get what? So let's take this as equation 4 sub x equals 4 into 4. What do you get? This becomes 0. F of 4 is what? F of 4 is given to be a. So what do we get? Let's write that equation. We substituted 4. So 16p 4q plus r is equal to a. Equation 5. Now sub x equals minus 4 into 4. You get what? This will become 0. F of minus 4 is what? B. So you get what? Again 16p minus 4q plus r is b. That is equation 6. Now we have 3 unknowns to find, so we have to use the third point. F of 0 is 0. So we can write what? We can write sub x equals 0 into 4. So then again, because this x, it becomes 0, qx term becomes 0. So you get p is 0, q is 0 because x terms, then r is equal to what? 0. R is equal to 0. So because f of 0 is 0, so we found 1. So then we can do what? Sub r equals 0 into 5. You get what? 16p plus 4q equals a. And do the same thing. Sub r equals 0 into equation 6. So you get 16p minus 4q is equal to b. Now you solve 8 and 9 simultaneously to get the p and q value. So I can do 8 plus 9. That gives me 32p equals a plus b. So p is equal to a plus b 32. Then I can do 8 minus 9, which is 8q equals a minus b. So q is equal to a minus b over 8. So then the new remainder when you divide by x cube minus 16x is what? Px squared plus qx plus r is 0, p is this value and q is that value. So you get a plus b over 32x squared plus a minus b over 8x. So that is the remainder when you divide by x cube minus 16x. Right. Okay, so now let's look at this exercise. Right, this is what? How to factor polynomials. Okay, you should know how to factor a polynomial completely. Right. So let's look at how to do this question. Right. Let's look at the first one. Right. First one, we do it by grouping. Okay. If you notice that you can create the same factor using first two terms and the next two terms, you can do grouping method. Okay. So here I am going to group these two and these two together. Then notice that from the first two terms, what can I take out? Common part x squared. Then what is left? X minus 1. Then from the second two, take a minus 1 out. Then again you get x minus 1. So that this method is called grouping, where you create the same factor using first two and the second two. Right. Now what is common between the first term and the second term? X minus 1 and x minus 1. So you take that out. So take x minus 1 out. From the first term, x squared is left. From the second, minus 1 is left. Now fully factor this. X squared minus 1 is what? You can write it as x minus 1 x squared minus 1 squared, and use difference of squares. So you get x minus 1, x minus 1, x plus 1. So that is what? X minus 1 square plus x plus 1. So that is the factored form of this polynomial. Why is factored form important? Because you can, using factored form, find the zeros. So what are the zeros of this polynomial? Zeros are 1 and minus 1. From this factor you get what? X equals 1. From this one you get x equals minus 1. So it is important to know how to factor a polynomial completely. So this is one method where you can use grouping. Right, now let's look at the second one. So second one is px 2x cube plus 3x squared minus 3x minus 2. Right, okay, look at this one. Grouping fails. Okay, you can't create the same factor, no, by taking something out. You can take x squared from the first term and the second term, you get what? 2x plus 3. But you can't create 2x plus 3 here in the second in the last two terms. So grouping doesn't work here. So for this type of question, the method is to find a factor first. Okay, you have to find a factor. Right, to find the factors, we have to first find the all possible zeros. So all possible rational zeros. So all possible rational zeros depend on these two values. So possible rational zeros of this polynomial depends on this. So remember this formula. Possible rational zeros are equal to factors of constant term divided by factors of leading term. Right, so using this we'll first figure out what are the possible factors. Right, so sorry, possible zeros are, using zeros we can find the factors. So what are the possible? So first let's figure out the factors of what? Factors of constant term. Factors of constant term. Factors of constant term is what? Constant term is minus 2, no? So what are the factors? Minus 1, 1, minus 2, 2. You have to figure also include the minus factors, okay? Because zeros can be minus also. So constant term has those four factors. What are the factors of leading term? Leading term is what? Leading term is 2. Again the same factors, no? 1, minus 1, minus 2, 2. Right. So then what are the possible rational zeros then? So you can do what? You can pick minus 1 and divide by minus 1. So you get 1. Minus 1 divided by 1, you get what? We are doing this formula. Constant term factor over leading term. Minus 1 over minus 1 is 1. Minus 1 over 1 is what? That is minus 1. So you get plus or minus 1. Both are there. Similarly, you can do what? 2 over minus 1, that gives you minus 2. 2 over 1 gives you what? 2. So plus or minus 2 works. What else? You can do 1 over 2 and minus 1 over 2. So that will give you what? two more possible zeros, minus, plus or minus half, because when we divide minus 1 from 2, you get minus half. When you divide 1 by 2, you get half. So those are the possible rational zeros, right? So we have 6 possible rational zeros. So using these 6, we have to first figure out one of the zeros of this polynomial. Then we can factor it fully, right? So now we are using what? Factor theorem. So I will start with minus 1. Will that work? I'm going to substitute. Minus 1 is a possible zero. Substitute x equals minus 1 into the polynomial. So you get what? 2 minus 1 cube, 3 minus 1 square, minus 3 minus 1, minus 2. What do you get? Minus 2 plus 3 plus 3 minus 2, which is plus 2. So this is not equal to 0. So then minus 1 cannot be a 0. We want to find a 0. If we find a 0, it's a factor using the factor theorem. So this won't work. So then try the next value, 1. What happens? 2 plus 3 minus 3 minus 2, right? That is 0. So then we know 1 is a 0 of the polynomial. Then from factor theorem, what do we know? X minus 1 is a factor. This is from factor theorem. Because p of 1 is 0 means x minus 1 is a factor of px. So in these types of questions where we can't do grouping, you have to do this. Somehow figure out one factor. Okay, right. So now we have figured out one factor. So now we have to figure out the rest. So this is how you do that. So p of x is what? 2x cubed plus 3x squared minus 3x minus 2, right? And we have figured out one factor. One factor is what? X minus 1. So take it as the divisor and do long division to figure out the quotient. Then we can use that to write it in division algorithm form to fully factor this, right? So x minus 1. So do the long division process. 2x cubed minus 2x squared, 5x squared minus 3x minus 2 plus 5x squared minus 5x. So you get 2x minus 2 plus 2, 2x minus 2, 0, right? So this is the quotient then. So now use the division algorithm form. So p of x is equal to what? Q of x times x minus 1 divisor. Remainder is 0 because it's a factor. No, x minus 1 is a factor. So my polynomial p of x is equal to what? What is q of, I will put the divisor in front, x minus 1. What is the q of x? 2x squared plus 5x plus 2, right? This one is a quadratic. No, you can factor the quadratic. So factor the quadratic to fully factor this. X minus 1, 2x and x. So you get plus 2 plus 1, correct? No, 2x squared, 5x plus 2. So this is the fully factored form for this polynomial, this cubic. So it has what zeros? X equals 1. So what are the zeros? We will write the zeros also. Zeros are first factor equal to 0, x equals 1. Second factor equal to 0, minus half. Third factor equal to 0, minus 2. So those are the zeros, right? So when you can't do grouping, you have to figure out one of the factors using factor theorem and this method, possible zeros method, right? Right, let's do the last one. G of x. Right, how to do this one? Let's see. Let's see. G of x is what? Third one. G of x is x to the 4 minus 2x cube minus x plus 2 minus 2x cube minus 2x cube. What is the other one? Plus, no, minus x plus 2 minus x plus 2. Right, this one, it looks like grouping works. No, I can group these two and create the same factor. No, see, I can take x cube out. I get what? X minus 2, and from the second 2 take minus out, so x minus 2, minus 1 out. Right, so then what happens? Right, then we have to take x minus 2 out, so we get x minus 2 x cube minus 1. Right, so this one we have to use one of the expansions that we need to memorize. This is an important expansion you will have to memorize. A cube minus b cube is equal to a minus b a squared plus ab plus b squared. Another important one that you should know is this one, a cube plus b cube, which is a plus b a squared minus ab plus b squared, right? So remember these two important expansions, right? So now using a cube minus b cube, you can fully factor this one. So you will get what? G of x is equal to x minus 2. 1 is 1 cube, so you can write it as x minus 1 x squared x times 1, so plus x, 1 squared is 1, right? This one you can't full factor further, okay? That we will learn later on. For now, because the discriminant is 0, less than 0, you can't fully factor this again, okay? We will learn to fully factor this also when we learn complex numbers, okay? When you learn complex numbers, you can factor this also. We can factor this when we learn complex numbers. Until then, we can only factor up to this point, right? Okay, so right, so in the next lesson we will start doing exam problems involving polynomials, factor theorem, remainder theorem, and division algorithm. Okay, we'll start with uh, problems from 2002, 3 or 4 and move until we come to 2024 problem, right? Okay, so we'll do that in the next lesson, right?